Hello, everyone. I hope this is recording, otherwise that would be very sad. Thank you very much for looking at this narrated presentation for the SCORE annual meeting in 2021. My name is Nina Schubach, and I'm presenting SCORE Working Group 156. And the title of our group is Establishing Active Fluorescence as a Primary Productivity Metric for the World's Coasts and Oceans. Okay. So as a tiny bit of background, there are these very nifty instruments called active fluorometers, or you might know them as FRFs. And at least in theories, these instruments have the capability to provide estimates of phytoplankton primary productivity autonomously and in situ and non-destructively and cost effectively and at really, really high resolution and all these good things. And obviously that's something everybody wants, and it would be wonderful. But as everybody knows, or anyone who ever tried to deploy one of these instruments on their research crews, getting from the measurement to productivity and carbon unit is not really as easy as it says on the box. And there's a lot of sometimes really quite complex details one has to consider to go from the measurement, or to decide how exactly to make the measurement, and then go from the measurement to primary productivity. And that has limited the approach a little bit over the last years. And I would say in like the last 10 years or something, the situation has simultaneously gotten a lot better and a lot worse, because there has been a lot of really exciting new developments and improvements in the design and the capabilities and the sensitivities of new instruments which are now being built. So that's really, really exciting. And there's also been a lot of development in our understanding of the, oops, sorry, this keeps jumping. There have been a lot of developments in understanding of how we interpret the measurements and how to best make the measurements. But at the same time, there have been slightly diverging instrument types and analysis approaches. And we're really at a point where we're risking that these slightly diverging approaches become incapable of being comparable to each other. And that's something we really want to avoid. And it's also something that makes it really hard to approach the subject for somebody who is not an expert, because the literature can be really, really confusing. And in many cases, it's actually something as simple as nomenclature. The different groups use different names for the same thing, and it just becomes incredibly confusing, which is a shame because it's a wonderful technique with a lot of potential. So we brought together all these people in Working Group 156. It's a wonderful international group of really smart people. It involves many people who've used these instruments for decades. And it also involves a lot of people who are really interested in this data for modeling and remote sensing algorithm development approaches without really using the instruments themselves very much, but who really want to understand what these instruments actually measure. And importantly, it also involves a lot of engineers and manufacturers of these instruments. And we all got together and defined our objectives. So one of the main objectives was to ensure intercomparability of different instruments and these slightly different instrument types I was mentioning. One of our main objectives really was to, at the end, provide some consensus best practice to the user, especially not the non-expert user. So we wanted to find out to what level we actually all agree with each other on how these instruments are best deployed and how the data is best interpreted. We already knew and then rediscovered very quickly that in the final analysis of the data, probably not going to reach agreement, because there are slightly different ways of how to interpret this data, of how to get from actual measurements of fluorescence or active fluorescence to something like an electron transport rate or even carbon assimilation. But that's great if there's different approaches, because you can compare different approaches to each other. So another thing we wanted to achieve is to develop some open source, keeps jumping, some open source software where a non-expert user or like semi-expert user can plug in their primary data and then try the different analysis approaches side by side. And then over time, we'll obviously find out which one is the best. Hand in hand with that, we want to develop a global database structure where all users of these instruments all over the world can feed in their primary data, which is now intercomparable because the instruments are intercomparable. And at least to me, the most exciting vision of this working group is to build a framework of getting globally consistent data of this primary active fluorescence data, which I think could be incredibly powerful for the validation and refinement of ecosystem models and remote sensing algorithms. Okay, so our group exists since 2019. We had a really nice, really long, like 2-week meeting in Vancouver in Canada right at the beginning, where we all got together and everybody brought their instruments, and we bickered a lot about whose instruments is the best and what's better about which instrument. And it was a really nice meeting where we actually spent a lot of time trying to identify where we agree and where we disagree. Yeah, and then we had our second meeting at the Ocean Science meeting in San Diego in 2002, where we talked a lot about how and where we could establish this global database. And yeah, we talked a lot about how to go about writing this big best practice document we eventually want to make, and who is writing which part. And yeah, and we gave a tutorial presentation at the Ocean Science meeting. Then since 2020, obviously we didn't have any in-person meetings anymore, but we had a lot of Zoom meetings. There's a lot of complication of finding a time which fits everyone on Zoom if you're all over the world. And during these meetings and during this time, we mostly talked about or discussed the best practice handbook, and we also finalized a Frontiers article, which is kind of a summary of this very big best practice handbook. That brings me to the publications. So as I said, we wrote Frontiers in Marine Science, Ocean Observations review about our work, which is kind of a very short version of the very big best practice handbook, which doesn't actually exist yet. But the article is out there, and there's a lot of useful information in there, I think, for users of these instruments. So please look at it. And on the Ocean Best Practice platform, we also have the very first version of the very big user guide, which is really just a placeholder at the moment. It's basically just what's going to be there eventually. But we're working very hard on filling in the gaps. And then this placeholder document will be replaced by an actual nice big user guide, and that will be there for community review, and it will be hopefully forever updated and always up to date. Other progress over the last year, there were 2 presentations at, obviously not in person, but yeah, meetings like this. One at the Aquatic Science meeting and one at the OCB summer workshop. And in other progress, I think something that became really obvious over this year, which is the 3rd year of our working group, is the development of quite a lot of collaborative research between different partners of this group, which otherwise wouldn't really have met or wouldn't ever have thought about working together, frankly. And there's a whole range of these collaborations where people got together and had different data sets. So now they're analyzing them together, or they actually had the same idea for an experiment. Now they're doing it together, or they're going to see together. And that has been really great. That's definitely a big advantage for everyone involved in this group. Upcoming activities, we do want to finish the first version of the best practice handbook, and we want to do this before the next Ocean Science meeting, so we can present the first version of this whole handbook at the Ocean Science meeting in Hawaii, hopefully in person. Then we've got a lot of new field activities, which are now, I would say, a lot more focused on critical gaps in our knowledge, which we identified because we all got together and saw where we disagree. And well, obviously the best way to solve disagreement in a group is to go to sea together and do the measurement, and then you'll see who's right. So there's a lot of that going on, which is wonderful. We do want to work more on this open source software. There is a preliminary version out there, but there's a lot of work we need to do to move this forward, and that's one of our main objectives for the next years. Yeah, and then we all want to go to Hawaii in person and lie in the sun and talk about fluorescence and yeah, present or launch the best practice handbook in a town hall session. Yeah, and that's everything. Thank you very much.